Hello, aspiring Hadoop admins. This is Shrikant, your Hadoop administration online training provider. Today I'm going to share with you about Yarn, the processing framework of Apache Hadoop 2. If you're ready to know, hit the like button. If you're new here, welcome to this channel and make sure you hit the subscribe button and press the bell icon to watch all my new updates. So let's start the theory of Hadoop processing framework Yarn. Now, before talking about the processing component, let's understand once again the components of Hadoop version 2. There are two main components. One is HDFS, the second one is Yarn. HDFS is the storage component, whereas Yarn is the processing component. Both components work on master and slave architecture. HDFS has master daemon, name node, slave daemon, data node. There must be at least one name node active at a time in HDFS architecture, whereas there can be multiple slave nodes working across the cluster. Then comes the Yarn, the processing framework. The full form of Yarn is yet another resource negotiator. The master daemon in Yarn is resource manager, whereas the slave daemon called as NodeManager. If we divide the overall component or these both component, we can see that under HDFS comes name node, whereas Yarn has resource manager as the master daemon. Now both master daemon work on separate machine, but slave machine should work on the same machine. So if this is machine 1 or slave machine 1, both slave daemon should work on the same machine. So data node, the slave of name node, and node manager, slave of resource manager. So they work on the same machine. All data node, they share their health report to name node machine. Slave machine cannot take their own decision. So data node cannot take decision to store the data by itself. It cannot directly receive data from a client machine and cannot store it. It need permission from name node machine. So name node decide which data node can store the data blocks. Similarly, in processing section, node manager cannot take their own decision to do processing. Node manager need permission from resource manager to do processing on certain file. So Yarn is the processing framework of Hadoop version 2. It's a processing framework of Hadoop 3 as well. The full form, as I said, it's yet another resource negotiator. What is the purpose of Yarn? Yarn can do processing on both MapReduce as well as non-MapReduce application. For example, when we were using Hadoop version 1, we were forced to do only batch processing on Hadoop cluster. But if any real-time data analysis or something like that, if we want to do, Hadoop 1 cannot do that. So Hadoop 2 has this processing framework called as Yarn, who can process non-MapReduce application as well. The framework is responsible for doing cluster resource management. Now in Hadoop 1, MapReduce was there to do the resource management, okay, and it was overloaded because at one side it has to do the cluster resource management as well as it has to take care of the analysis as well. Okay, here the task is divided between multiple co-component as well. This is our client machine and this is a resource manager machine, a server where resource manager daemon is running. Resource manager have its own co-component called as when client machine submit job to resource manager, in return resource manager assigns application ID. Using this application ID, client machine or user can track the overall progress of their submitted job. So resource manager have scheduler and application manager as its co-component. Now these two co-component plays a vital role in data processing. These are a slave machine, node manager. and all node managers share their heartbeat via the health report via heartbeat. They share their heartbeat according to the specified time. Now, scheduler is the co-component who is responsible to find out machine who has a relevant data file, as well as so scheduler targets those machine which has relevant data block plus processing capacity. An application manager is the one who informs the targeted node manager to start containers and to start application master for the processing. And wherever the data block and processing capacity is available, application manager starts container and application master only on those node manager. Like in this case, let's assume data block and processing capacity is available on node manager 1 and node manager 3, but it's not there on node manager 2. That is why application manager didn't start container and application master on node manager 2. We will understand what exactly happens. What happens in the background when we submit our job to yarn processing framework. Let's consider this is our client machine or user who wants to process some XYZ file. So client or user submits the job to resource manager. In return, resource manager provides an application ID to user. All node manager act as a slave machine for resource manager who are ready to accept job to do the processing. Scheduler comes into picture. Okay, scheduler comes into picture and scheduler find out those node manager where processing capacity is available as well as relevant data blocks are available. Let's say client submits a job, says that client want to process a.txt file. Now we know that when we copy a file into hdfs breaks that file into multiple data blocks, and those data blocks get distributed across the cluster. Now there is a possibility some data blocks are available in this node manager or this slave machine, or some data blocks are available in this slave machine and some are in this slave machine. So scheduler job is to find such slave machine where relevant data blocks plus processing capacity both are available. Then only processing can take place on that slave machine, right? So scheduler find out those machines where processing can take place. Then let's assume that on this slave machine resources are available like 2 GB RAM, 2 CPU, 2 GB hard disk. Okay, and relevant data blocks A, C, and E, three data blocks are available on this slave machine. Now, application manager comes into picture, and application manager starts container number 0 and application master for this particular job. Okay, so if there are 4 jobs running in this slave machine, so we should remember that 4 application masters are running on this machine. Okay, on this machine. So there will be one application manager per cluster, and there can be multiple application master, depends on how many jobs are running in that slave machine. So if 10 jobs are running in this slave machine, there will be one application master per task. Okay, so client submits job, and when it get distributed across the slave machine, it become task. So let's say if 10 tasks are running on this machine, so one application master will run per task. Okay, so in this example or in this explanation, there's only one job we have submitted. Okay, so one application master is running in this slave machine. Now as soon as application master comes into picture, it send a request to application manager, and it send a registration request. Okay, application master sends a registration request to application manager. In return, application manager shares an ID with this application master. Using this ID, application master maintains connection with resource manager. Okay. So as long as job is running on this machine, as long as task is running on this machine, application master will maintain a connection with application manager. Okay. So as soon as application master gets the registration ID, it sends a list of required resources, okay, for the analysis of data blocks. Okay. Now, so it sends a request to application manager, and in return application manager gives the permission. Okay, it grants the permission that okay, you can use the required resource to complete this processing. Now application master inform node manager to create more number of containers to complete this processing. So first container number 0 is created by application manager, and the rest required number of container will be created by node manager. Now if application master informs node manager that we got a permission to complete this task and we are allowed to use the relevant required resources on this machine, so let's start the processing. Now as soon as node manager get the information, it creates number of containers to complete the processing. Okay, complete the processing. Now as long as job is running on this machine, application master will keep calculating that how much resource is still required to complete the processing. So initially it says that it need 2 GB RAM. After some time, when it will calculate and it will find that okay, 2 GB RAM is not required, 1.5 GB RAM is enough. So it will send a request with application manager, and based on that request, application manager will say that okay, you are allowed to use 1.5 GB RAM. So that 0.5 GB is in a reserved state now. Okay, and can be used by some other processing. Similarly, for CPU and hard disk, application master will keep calculating that whether it require 2 CPU or 4 CPU. Based on the analysis, it will send the information to manage application manager and will do according to the guidance, okay, according to the permission from application manager. Now as the processing is getting completed, so in first case it was 100% pending, then next case some 90%, 80%, so requirement gets reduced, right? So based on that, the number of containers also will be created by node manager. Okay, now once the processing is completed, application master will inform application manager that processing is completed. Stop stop allowing us to use cluster resource. Okay, and based on that information, based on that message, application manager will stop this node manager by using any cluster resource. Okay, second message application master will send to node manager telling that the processing is completed. Please inform resource manager via your heartbeat. Okay, now as soon as node manager gets the message, it sends a message to resource manager saying that processing is completed. And since the processing is completed, container and application master, they will kill themselves. Okay, and here the processing of the submitted job gets completed. Okay, here we have completed the explanation of yarn application submission, that what exactly happens behind the scene. If you like this video, hit the like button, share with other friends, subscribe the channel, press the bell icon to receive more videos like this. And if you have your requirement, you want to understand any Hadoop related topic, okay, please do let me know in the comment box. We'll meet next Sunday. Thank you.